Hello guys, welcome once again to the Logic Talks. In this session, we will be taking one more question on DFA. It is a very important question and very common in university examinations. So let us see the question. The question is to design a DFA over the input alphabet 0, 1 such that it accepts all the binary strings whose decimal equivalent is divisible by 3. For example, 0, 1, 1, 110, 1001, etc. These are divisible by 3, and 10, 101, 1000. These are not divisible by 3, so should be rejected by the machine. So this is what we have to do. So let us now move on to the solution. So let us see in this table. As we can see that first column is giving us the decimal numbers ranging from 1 to 10, and their binary equivalent are given in column number 2. So binary equivalent for 0 is 0, for 1 it is 1, and for 2 it is 1 0, for 3 it is 1 1, for 4 it is 1 0 0, and so on. So let us now see the remainder that we are getting by dividing the decimal number by 3. So that is given in column number 3. So when 0 divided by 3, the remainder is 0, 1 divided by 3, remainder is 1, 2 divided by 3, the remainder is 2, and 3 divided by 3, the remainder is 0, and 4 divided by 3, the remainder is 1, and so on, it repeats. So with this we can see that we are getting three distinct values that we are getting as a remainder when we are dividing a number by 3. So, and again they are ranging from 0 to 2, 0, 1 and 2. So what we can do is that we can make three distinct states, one for each remainder value, and then we can construct a DFA such that it lands on the state representing the appropriate remainder value for the respective input. So as we can see in the column number 4, we have constructed a state corresponding to the remainder value. For 0 we are having state q0, for 1 we are having state q1, and for remainder 2 we are having state q2. So what we can do now, we can construct a DFA such that for a particular binary input it should land on the appropriate state. The appropriate state here means whatsoever state is corresponding to the remainder which I will be getting by dividing that binary equivalent decimal number with 3. So let's take an example. If we are having 0 as input, then it should lead me to state q0 because corresponding remainder here is 0. If I am having binary 1 as input, then it should lead me to state q1 because here I am having 1 as respective remainder value. So if I am having input 1 0, then it should lead me to state q2 because the corresponding remainder here is 2. If I am having input value 1 1, then it should lead me to state q0 because corresponding remainder value here is 0. So if I am having input 1 0 0, then it should again lead me to state q1 because again the remainder value here is 1, as we can see in the table. So let us see this here with the help of a state diagram. So here we will be requiring three states, q0, q1 and q2. q0 is the initial state and I have made it as a final state also, because here we are looking for the numbers which are exactly divisible by 3, means which on dividing by 3 are giving me remainder 0. So I am concerned about the state q0 because it is related to the remainder 0. So let us see, whenever we are having input 0, it should remain on state q0 itself. So for this we have made a loop. q0 on getting input 0 will remain on q0 itself, and again whenever we are dividing 0 by 3, the remainder is always 0. So next we can see here we are having 1 as our input. So if we are having 1 as our input, then it is leading us to the state q1. So it is leading us to the state q1. So if we are having 1 0 as our input, then it should lead us to the state q2. Again, if we are having 1 1 as our input, 1 1 as our input, then it should lead us to the state q0, 1 1. So here it is leading us to the state q0. So if we are having 1 0 0 as our input, so it should lead us to the state q1, 1 0 0, it is leading us to the state q1. So after this, if we are having 101 as an input, then it should lead us to the state Q2. So 101, 101, it should lead us to the state Q2. So on having 110 as an input, it should lead us to the state Q0. So as we can verify it from here, like Q0 to Q1, on one as an input, it is moving from Q0 to Q1, and from another one as an input from Q1 to Q0, and for 0, it is remaining on the state Q0, and that is the accepting state. So with this, our DFA is complete. So now let us see the corresponding transition table. So as we can see in the corresponding transition table, Q0 is the starting and final state. Q0 on input 0 is leading to state Q0. Q0 on input 1 is leading to state Q1. Q1 on input 0 is leading to state Q2. Q1 on input 1 is leading to state Q0. And Q2 on input 0 is leading to state Q1. And Q2 on input 1 is leading to state Q2. So I hope you are able to understand the pattern that has developed so far. The pattern is like, for divide by 3, it is like Q0, Q1, Q2, and again Q0, Q1, Q2. So this is a pattern. So if it would have been like divide by 4, then the pattern would have been Q0, Q1, Q2, Q3, and number of states would have been 4 states then. Okay, and if it would have been like divide by 5, then the pattern would have been Q0, Q1, Q2, Q3, Q4, and again repetition Q0, Q1, Q2, Q3, Q4, and in that case the number of states would have been 5. So I hope it is clear to all of you. It is quite a simple question but very important from university examination point of view. So that's all for this question, and I hope it is clear to all of you. I will be coming with more such questions. For more such videos, please like, share, and subscribe. See you in the next video. Till then, take care. Bye.